Welcome to this OST2 lecture about using ESAPI to enable the TPM built-in parameter encryption protection against machine-in-the-middle attacks. First, we'll have a refresher from TC 1101 about parameter encryption and how it works. The TPM supports 4 types of sessions: trial session, policy session, HMAC session, and an audit session. Audit session is a special purpose one. We have a separate slide for it, and we'll just quickly go over it. Now, the other 3 session types are interesting because HMAC session and policy session can be used to enable parameter encryption and protect the command going to the TPM and the response of the command going back from the TPM. A trial session is used to create new TPM policy digests. We have a dedicated lecture in this course, TC 1102, about TPM policies and how to create them. Here we have an example using TPM2 tools how to enable parameter encryption. We create a primary key and then we use that TPM primary key to add entropy to our session key, which is created when we create a TPM session of HMAC type. And then this session can be used in any following TPM2 tools used to protect our TPM operations. Now, about this special audit session type. In fact, audit sessions can also have parameter encryption enabled. It is just rarely that we'll use audit sessions. Their purpose is quite literally to audit the TPM command. It instructs the TPM to compute a hash digest over the command and its response. And here is the typical flow. Because audit sessions are not that common, we recommend using HMAC sessions for enabling parameter encryption and these machine-in-the-middle attacks. We also learned that parameter encryption has limitations. The design of parameter encryption protects only the very first parameter of any TPM command. And this is why, for example, over the years, the TPM2 encrypt decrypt was deprecated in favor of a new version, TPM2 encrypt decrypt 2. And the major change was that the payload, the data to be encrypted, was put in the first place so it can be protected by parameter encryption. And in most commands that have sensitive information inside the TPM, the first parameter contains that sensitive information. This is also true when generating keys. The insensitive parameter of the key generation process is the first parameter of the TPM to create primary TPM to create. And parameter encryption can protect the communication from both sides. The TPM expects commands to come encrypted, and this is the responsibility of the TPM to TSS to do. And the TPM can then respond with encrypted commands that the TPM to TSS has to decrypt using the generated session key that was established between the TPM and the host, which is our application. Now, there are session attributes that are important to defining the behavior of the TPM session, and we'll look into it now. The different session attributes define different behavior. The important ones for parameter encryption are continuous session, because by default TPM sessions expire after they're used, and we would like, once we set up that parameter encryption session, that MITM protection, to be able to reuse it again and again. Of course, from some security perspective, and depending on your requirement, you can decide to have different sessions created. So you have new entropy, new session key, and so on, and that's also valid. It really depends on your use case and or your application. Then the other 2 important flags are the decrypt and the encrypt flag, and they define: are we going to encrypt the commands going to the TPM, or we are also going to encrypt the responses? And we can choose one or the other, or both. Let's take a look how to enable parameter encryption using ESAPI. First, we need to have a primary key that will use as seed for the session key. And then we need to use the ESAPI API for starting a TPM session to create such TPM session of HMAC type. Once this is done, we need to make sure to set the proper session attributes to enable parameter encryption, which are decrypt and encrypt. So we request the protection of both the command request and the command response. And of course, if we want to reuse this parameter encryption session, we have to set the continuous session bit. Then we perform the different operations that we want and make sure we placed that TPM session handle inside the 3 authorization slots of the command that we're invoking. Is that child key generation? Is that signing, encryption? Whatever the operation is, make sure to add that session in the authorization slots of that command. And this is usually placed after the first authorization slots. Maybe there's a password authorization, maybe there's other policy authorization. In summary, we need to start a TPM session using ESYS_startout session of type HMAC. Then we need to set the proper attributes for continue session for encrypt and decrypt to protect the commands request and response. And then once the session is used and we no longer need it, we need to flush the context. And of course, don't forget we need entropy for the session key, and that can come from a primary key which is known only to the TPM. So we create it. It works very well. We can add salt to the session. Of course, if we want higher entropy, we can use that same primary key also as bind, and then we'll have a salted and bound session. We talked more about these types of session in TC 1101, and if you want to learn more, then I really encourage you to go in the previous course and find that lecture and watch the video. Let's take a closer look at the ESAPI API for starting a TPM session. We need to provide our ESYS context as usual. Then we need to provide an object entity from where we'll receive the salt for the session key. And as mentioned, this can be the primary key. Then we can also have a bind. And here again, we can place the primary key. Then we have the 3 authorization slots, and we have some extra inputs here that can be set by us or by the stack. The non-scalar can be no. The session type can be one of 4 types, as we mentioned: trial for creating policies. We'll talk about that in a dedicated lecture. Then a policy session to authorize a policy. This is also covered in this course. And of course, you can also use a policy session with parameter encryption to achieve the machine in the middle protection, but it is mostly recommended to use the HMAC type for that purpose. And the special audit type, which also can have parameter encryption, but you would be invoking extra operations in the TPM to compute the digest of the command and its response. And if you don't need it, then this is extra work putting on the TPM and its performance, which I don't think is really needed in most situations. So HMAC type it is. We selected the type of TPM session, and now we need to choose also the type of parameter encryption. There are 2 types of parameter encryption that the TPM supports: XOR and EAS CFB. The EAS CFB offers higher guarantees. This is the session key will be symmetric. The only supported size of EAS is 128 for parameter encryption. The hash algorithm for the TPM session supporting parameter encryption can be any of the supported hash algorithms by the TPM. And of course, when we get to policy, you see that it has to match the hash used to generate the policy. But for now, we can just use SHA-256. Then we have the API for setting the important session attributes. And this is ESYS_TRSES, one word, with SS _ set attributes. We provide our ESAPI context, then we provide the handle to the session created by the previous call, the one that created and started the TPM session, and then of course we need to set the flags and the mask using the session attributes, and here's an example how to do that. Now, generating the session and setting the flags is not enough to make use of this protection that is built in the TPM. You need to make sure that you use this newly generated TPM session, you've set the flags, and it is included, the handle to that session, in your calls to the different TPM operations. ESYS create, ESYS load, sign, and so on. And usually this is placed at the second authorization slot, second out of the 3. Example solutions with machine in the middle protection are available at our code repo. There you can find solutions of all the different labs. If you have questions, you can always write to us in the discussion boards after each unit.